On the 27th of June, 2026, the beams stopped circulating. After almost 2 decades, the most powerful machine ever built by human hands went quiet beneath the border of France and Switzerland, and the lights on the control room screens went flat. The official reason is dull and completely reasonable: an upgrade. It will sleep until 2030. But 19 years before that switch was thrown, 2 mathematicians in Moscow uploaded a paper to a public physics archive, and the title of that paper was 4 words long: Time Machine at the LHC. It was not a joke, it was not a blog post, and it was not written by cranks. It went through peer review, and it was printed in a real journal. And in the 19 years since, as far as I have been able to find, not one physicist has ever published a formal reply to it. The question is not whether they built a time machine under the Alps. The question is why the most serious institution in physics let a paper with that title stand in the literature, unanswered, for 19 years, and what happened to that machine in the meantime. For several days I went through the arXiv listings, the incident reports, the trigger specifications and the debunks, and what I found raises far more questions than it answers. To understand why this refuses to die, you have to start with the 2 people who wrote it. Irina Arefeva and Igor Volovich are mathematical physicists at the Steklov Mathematical Institute in Moscow, one of the most respected pure mathematics institutions in the world. Neither is a fringe figure. On the 15th of October, 2007, 11 months before the Large Hadron Collider fired its first beam, they posted a paper to the arXiv preprint server, catalogued as 0710-2696, and it was published the following year in the International Journal of Geometric Methods in Modern Physics. Their argument was this: everyone at the time was arguing about whether the LHC might create microscopic black holes. Arefeva and Volovich pointed out that if the same assumption behind that fear was true, that gravity becomes powerful at the energies the LHC reaches, only a few trillion electron volts, then the collider would not just make black holes, it would make traversable wormholes, regions of space-time containing what physicists call closed time-like curves. In plain language, loops in time, and they calculated that the odds of producing one were roughly the same as producing a black hole. They even described what the signature would look like in the detectors, so that someone could go and check. Now here is the calm, official, entirely defensible version of all this, and it deserves to be stated properly. That paper was a conditional. It said if TV-scale gravity is real, then this follows. TV-scale gravity was never found. The LHC hunted for extra dimensions and microscopic black holes for years and came back with nothing. What it did find, in July 2012, was the Higgs boson, exactly where the standard model said it would be, a discovery that won a Nobel Prize. Everything the machine does is published, peer-reviewed, and monitored by safety boards who concluded, repeatedly, that it endangers nobody. There are no portals. There is no doorway. The paper was a legitimate exercise in speculative phenomenology, of the kind physicists write all the time, and the reason nobody rebutted it is that there was nothing to rebut. That is the settled account. But here is where people started asking questions, because in the very same year, at almost the very same moment, a second group of physicists was arguing something far more disturbing, not that the machine might reach into time, but that time was already reaching back into the machine. Start with the part that is not speculation at all. In 1978, the American physicist John Archibald Wheeler, the man who coined the term black hole, proposed a thought experiment. Send a single particle through an apparatus, and then, after it has already passed the point where it must supposedly have chosen to behave as a wave or a particle, change the apparatus. Wheeler asked whether the particle's past could be altered by a decision made after the fact. For decades, it was philosophy. Then, in 2007, a French team at the Institut d'Optique ran it with single photons and published the result in Science. In 2015, a team led by Andrew Truscott at the Australian National University ran it with something far harder, a single helium atom, a real object with mass, and published it in Nature Physics. The result held, and Truscott's own description of what his experiment proved is worth hearing exactly as he said it. It proves that measurement is everything. At the quantum level, reality does not exist if you are not looking at it. And that is where things stop being merely strange. Because in July 2007, 3 months before the Moscow paper, a Danish physicist named Holger Bech Nielsen at the Niels Bohr Institute and a Japanese physicist named Masao Ninomiya at the Yukawa Institute in Kyoto posted a paper to the same arXiv with a title just as blunt: A Search for Future Influence from the LHC. Their claim was that the Higgs boson is so unwelcome to the structure of the universe that its future creation would send an influence backwards through time to prevent itself from ever being made. They wrote it as mathematics, an imaginary term added to the action of the universe, allowing conditions in the future to constrain the present. And Nielsen put the prediction in words a child could understand. All Higgs-producing machines, he said, shall have bad luck. So look at the luck. In October 1993, the United States Congress cancelled the superconducting supercollider, a machine larger than the LHC, already partly dug into the ground in Texas after roughly $2 billion had been spent. Nielsen and Ninomiya cited that killing as evidence. Then their own prediction went to work. On the 10th of September 2008, the LHC fired its first beam. 9 days later, on the 19th of September, a single faulty electrical connection melted. Liquid helium tore through the tunnel. Dozens of the enormous superconducting magnets were wrecked, and the most expensive machine on Earth went dark for over a year. On the 3rd of November 2009, as it was finally clawing back to life, a bird dropped a piece of bread onto an outdoor electrical substation and shut it down again. On the 29th of April 2016, an animal crawled into a transformer, and the collider stopped for a third time. And Nielsen and Ninomiya had gone further than prediction. In a follow-up paper, they formally proposed that CERN run a test. Draw one card at random from a deck of roughly 1 million. Almost every card says carry on. A handful say restrict the beam. One says shut the machine down. If the universe wanted the Higgs suppressed, they argued, the odds would bend and the machine would draw the impossible card. CERN never drew. But what I haven't told you yet is the number that came back when the machine finally caught what it was hunting. The Higgs boson has a mass measured at roughly 125.1 giga-electronvolts. That number, combined with the mass of the top quark, determines whether the vacuum of our universe is stable. And when physicists ran the calculation, Degrassi and colleagues in 2012, Batazzo and colleagues in 2013, in a paper literally titled An Investigation of the Near Criticality of the Higgs Boson, the answer was not stable, it was metastable. Our universe sits, by the finest of margins, on the knife edge between a stable vacuum and one that could in principle decay, a bubble of true vacuum expanding at the speed of light and rewriting everything it touches. Stephen Hawking wrote about it publicly, warning that the Higgs potential might become metastable at higher energies, with catastrophic consequences. Of all the values that number could have taken, it landed on the boundary. And Nielsen's entire model rested on the claim that nature has a problem with this specific particle. Here is the strongest version of the case. The machine's own record-keeping means nobody can ever go back and check. The LHC sees 40 million bunch crossings every second, around 1 billion collisions, and its trigger system keeps roughly 1,200 events out of every 30 million. Everything else is deleted in microseconds and is gone forever. Over 99.9% of everything that machine ever witnessed was destroyed unexamined by a system programmed in advance to know what was interesting. And we already know signals can appear and vanish there. On the 15th of December 2015, both Atlas and CMS reported an excess at 750 giga-electronvolts, 3.9 sigma and 3.4 sigma, two independent detectors. The same bump. Around 500 theory papers were written about it. By August 2016, it was gone, as though it had never been. Put it together. A peer-reviewed paper predicting time machines that nobody ever answered. A second, predicting sabotage from the future. A lab experiment proving a particle's past can be settled after the fact. 4 decades of accidents that fit that prediction. A Higgs mass sitting exactly on a cosmic knife edge, and a machine that throws away all but a whisper of what it sees. But before you say yes to any of it, there is another side we cannot overlook. and it is brutal. The Moscow paper's conclusion depends entirely on a premise the LHC itself disproved. No TeV-scale gravity, no extra dimensions, no micro-black holes. It also required exotic matter, violating the null energy condition, something never observed anywhere in nature. Nobody rebutted the paper because the machine rebutted it, experimentally, for 18 years. Cosmic rays have struck our atmosphere at energies far beyond anything the LHC produces for 4 billion years, and no wormholes have opened. In 1992, Stephen Hawking published his chronology protection conjecture in Physical Review D, arguing the laws of physics conspire to prevent closed, time-like curves, as he put it, making the universe safe for historians. Wheeler's experiment does not send information backwards. It shows that the question, what did the particle do before we looked, has no answer, which is strange, but is not time travel. As for Nielsen and Ninomiya, the arXiv moderators quietly reclassified several of their papers into the general physics bin. The community reaction was close to unanimous, and Nielsen himself published a paper conceding the card game could only produce an apparent success, no matter what happened, which is another way of saying the test could never fail. Enormous experimental machines break. The trigger algorithms are public documents, not secrets, and a 3.9 sigma bump that evaporates is precisely why physics demands 5 sigma in the first place. And yet, the paper is still there, still catalogued, still unanswered in a field that answers everything. The Higgs really did come back sitting on the boundary between a stable universe and a doomed one. Over 99% of everything the collider ever saw really was erased in real time by a machine deciding in advance what mattered. And it is now dark until 2030, while CERN's council voted in May 2026 to make its successor the priority, the Future Circular Collider, 90 kilometers around, 15 billion Swiss francs, a machine that will not switch on until the 2040s. That is an enormous amount of coincidence stacked around one silent tunnel, don't you think? So which is it? A machine that brushed against something in the structure of time, whose evidence was deleted at 40 million frames a second by a filter nobody ever needs to explain, described in advance by mathematicians nobody wanted to argue with, or a beautiful, ordinary instrument that did exactly what it was built to do, surrounded by 2 speculative papers, a run of very normal bad luck, and a species that cannot look at a coincidence without seeing a hand behind it. The physicists say the time machine was always just a conditional clause in a paper whose condition turned out to be false. The paper says what it says, and it is still sitting there. And the only version of the last 19 years anyone can now examine is the tiny fraction that a machine and the people who programmed it decided was worth keeping.